Hello friends, this is Hemant Arora from ElectroHack and welcome to the tutorial of PIC18F4520 controller and programming using C18 compiler part 2.2. In this tutorial, a bit detailed description of the pin configuration of 4520 has been provided and explained. So let's get started. Pin 1 has the working of MCLR, VPP and RE3, where MCLR stands for master clear, that is, when a continuous 0 is applied on this pin, it will reset the device. VPP is the input voltage to be set for the programming feature. RE3 is the digital input to port E, but this is the only digital input and not the output. Pin 2 works as the RA node and AN node, where RA node is the digital input output pin 0 for port A and AN0 is the analog input pin 0. Pin 3 is similar to pin 2. It's just that the pin 1 is used instead of pin 0. Pin 4 has the function of RA2, AN2, V reference and CV reference, where V reference is the reference voltage input provided for the analog to digital conversion and CV reference is the reference voltage output for the comparator. Pin 5 works as the RA3, AN3 and V reference positive, which is the higher reference value for analog to digital conversion. The previously discussed was on pin 4, which was the lower reference value. Pin 6 works as the RA4 TO clock C1 out, where TO clock is the external clock input for timer 0 and C1 out is the input for the comparator 1. Pin 7 works as RA5 AN4 SS HLDIN and C2 out, where SS is the slave select input for the SPI operation. HLDIN is the input to detect higher or low voltage value. Pin 8 works as the RE0, RD and AN5, where RD means the read control for PSP mode. Pin 9 works as RE1, WR and AN6, where WR is the write control signal for the PSP mode. Pin 10 works as RA2, CS and AN7. CS is the chip select control, again for the PSP mode only. Pin 11 and 32 are used for the positive supply for IC manufacturing, and on the other hand pin 12 and 31 completes it by negative supply. Pin 13 works as oscillator 1, clock 1 and RA7. Oscillator 1 is the crystal oscillator input and clock 1 is the external clock source input to provide or use the external clock. Pin 14 works in the similar manner to pin 13. Pin 15 works as RC0, T1 oscillator and T13 clock. T1 oscillator 0 is the oscillator input for timer 1 and T13 clock is the external clock input for timer 1 or 3, whichever we are using. Pin 16 works as RC1, T1 oscillator 1 and CCP2. T1 oscillator 1 is the oscillator input for timer 1 as of pin 15. CCP2 is the capture 2 input, compare 2 output and PWM2 output signals. Pin 17 works as RC2, CCP1 and P1A, where P1A is the output provided for enhanced CCP1. Pin 18 works as RC3, CSK and CSL, where CSK is the synchronous clock input for SPI mail and SCL for I2C mail. Pin 19 works as RD0 and PSP0. PSP0 is the very first pin of parallel slave port data. Pin 20 to 22 works in the same manner of pin 19. Pin 23 works as RC4, SDI and SDA. SDI is the SPT input data and SDA is the I2C data input and output. Pin 24 works as RC5 and SD node, where SD node is the SPI data output. Pin 25 works as RC6, transmitter and CK, where transmitter is the USART asynchronous transmit and CK is the clock signal for USART. Pin 26 works as RC7, receiver and DT, Receiver is the receive signal for USART in asynchronous mode, and DT is the data input for USART in synchronous mode. Pin 27 to pin 30 works as RD and PSP, whose work is as described above. Pin 33 works as the RB0, INT0, FLT0 and AN12. INT0 is the pin to provide the external interrupt. FLT0 is the PWM fault input for enhanced CCP1, where CCP is the capture compare PWM. Here, pin 34 to 36 again have the similar work as prescribed previously, only with the values of the output signal changed. Pin 37 has the special feature of KBI0, which is the interrupt on change input. Now at last, again these pins work upon the previously described features. So that's all about pin description of 4520. Hope you learned. For any queries, questions or suggestions, you can post or mail to provided links. Thank you.